Hello viewers, you're welcome to my YouTube video today. I'll be solving the sixth question in the West African Examination Council 2023 Mathematics Past question. I will solve question 6A. Okay. Now this question inculcates your knowledge of set theorem and probability. Okay. M equals n such that 2n minus 3 is less than or equal to 37. When n is a counting number, I write down all the elements in M. If a number is selected at random from M, what is the probability that it is a alpha multiple of 3, beta factor of 10? Okay, without much wasting time, I'll solve this problem. To the first part of the problem, that's 6AI. I'll write out the equation. It's been written in set builder's notation. M equals, a curly bracket was open, n such that 2n minus 3 is less than or equal to 37. So I'll bring out the equation. 2n minus 3 less than or equal to 37. I will make 2n subject of the formula. Then I'll have 37. I need to add plus 3 to both sides of the inequality. Okay, so minus 3 plus 3 is 0. 37 plus 3, so our 2n less than or equal to 40. Now I need to divide both sides of the inequality by 2. N will now be less than or equal to 40 divided by 2. N is less than or equal to 20. Okay? Now that I've gotten my n, it means that if M is likened to be the universal set, the element of n has been defined by this equation, meaning it has to be M will now be equal to, I use a curly bracket, all the numbers, real numbers, or rather, all the counting numbers from 1 to 20. 20 is inclusive because the inequality is less than or equal to. So I'll write my values here. Okay. Now I need to count the total number of elements of M. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, and 20. Hence, the number of elements in M equals 20. Okay? Now to the second part of the question, that is AII. Here I'm expected to, if a number is selected at random from M, what is the likelihood or the probability that it is a multiple of 3? Now the alpha part of the question. I need to get the numbers that are multiples of 3 and that are subsets of M. Remember I said M is likened to be the universal set in the question. Okay, so I'll open a curly bracket. The multiples of 3 are 3 times 1 is 3. 3 is, as an element, is a subset of M. So I write 3, comma. The next multiple of 3 is 3 times 2, 6. 6 is a subset of M. The next one is 3 times 3 is 9. 9 is a subset of M, so I'll write it here. 3 times 4 is 12. 12 is a subset of M. 3 times 5 is 15. 15 is a subset of M, and 3 times 6 is 18. I'll write 18, and then I'll close my curly bracket. So I have 6 digits here, okay? So I can say the total number of digits that are subsets that are multiples of 3 in M are 6 in number. So to answer the alpha, I need to find the probability of a number. So if I pick a number from M, what is the likelihood that a number is going to be a multiple of 3? It will now be the total multiples of 3 that I have. I have 6 multiples of 3 divided by the total number of digits or the total elements in M, which is 20. So 6 divided by 20 is 0.3. So the likelihood of picking a number from the universal set M and for that number to be a multiple of 3 is 0.3. Okay, now to the beta part of the question. What is the likelihood of picking a number that is a factor of 10? So I need to get all the factors of 10. The factors of 10 are numbers in which if I divide 10 by the number, it's going to give me a whole number. So 10 divided by 1 is 10. So 1 is a factor. 10 divided by 2 is 5, so 2 is a factor. 10 divided by 3 will leave a decimal point. It will leave a decimal, there will be a remainder. 10 divided by 4, of course there's a remainder. 10 divided by 5 is 2, so 5 is a factor. Now, if you look at 6, 7, 8, 9, if you divide 10 by any one of these numbers, you're going to have a decimal fraction. You wouldn't want that to happen, so it means they are not factors. 10 divided by 10 is 1, so 10 is a factor. Now, 20 is not, because 10 divided by 20 is 1 over 2, which is a decimal fraction, 0.5. So the factors of 10 that are subsets of m are 1, 2, 5, and 10. So I'll close my curly bracket, meaning the total number of elements of the universal sets that are factors of 10 are 4 in number. Now, the likelihood or the probability of picking a number that is a factor of 10, I'll say the probability of a number selected from m and for that number to be a factor of 10 will be equal to the total factors of 10 that I have, 4, divided by the total number of digits or elements of the universal set m, which is 4, or rather 20. So 4 divided by 20 is 0.2. So the likelihood of picking a number from m and for the number to be a factor of 10 is 0.2. So which means the likelihood of picking a number that is a multiple of 3 is higher than picking a number that is a multiple of 10. Obviously, from the value, you can see 0.3 is greater than 2. So we have more numbers that are multiples of 3 and less that are what? Factors of 10. Okay, that is the solution to question 6A of the West African Examination Council 2023 Mathematics. Thank you for watching my YouTube video. If you have not subscribed, kindly subscribe, hit the subscribe button, and I will sincerely appreciate that. See you in the next video. Bye bye.